All right, so today we're gonna keep on going with vertex form, but before we get started there, I want you to take a look at these and see if you can tell me the y-intercept. So our y-intercept of a parabola comes from letting x be equal to 0. Whenever you're asked for a y-intercept, x equals 0 is what you want to think about. So in this case, I would, wherever there is an x, I would put a 0. And then evaluate it. So first my bracket, 0 plus 2, which is 2, squared. And then, whoops, minus 7. 2 squared minus 7. And then 2 squared is 4, and 4 times 4 is 16, which would give me y equals 9. So 0, 9 would be my y-intercept. For here, same thing, if I let all my x's be zeros, notice it takes them all away. So standard form is whatever that number, that constant number is at the end, that is going to be your y-intercept. And then here for this last one, 0 plus 4, 0 minus 1, which would equal negative 2 times 4, and 0 minus 1 is negative 1. So negative 2 times 4 times negative 1, which is going to give me a positive 8. So 0 times 8. And so this is how you get your y-intercept, just by simply letting x be equal to 0. Okay, so we're going to keep going with completing the square, and we're going to do a couple of application questions too. So these are kind of word problems where we need vertex form in order to solve. All right, so let's start. The big thing yesterday was remembering that x equals negative b over 2a. So that is our big formula, even though it's a little formula. It's our big formula to find the x coordinate of our vertex. Once we know the x coordinate of our vertex, we can sub it back into our equation to get our y value. And then we just use the a value from standard form to write our equation in vertex form. So let's do this. So x, oops, sorry, not x. A equals 1, b equals 16, and c equals 3. Now, x is equal to negative b over 2a. So in this case, negative 16 over 2 times 1, which is negative 8. And then my y value, wherever there is an x, I'm going to put a negative 8 in for it. And negative 8 squared is 64. And then 16 times 8 is negative 128 plus 3. This is going to give me negative 64 plus 3, which is negative 61. And then my equation using my a value, which is 1. So then x, and then I put this negative 8 back into the brackets, becomes a positive 8 squared minus 61. Okay, let's try this one. 4x squared minus 8x plus 1. So a equals 4, b equals negative 8, c equals 1. X is equal to a negative b over 2a. So a negative 8 is going to give a positive 8 over 2 times 4, which is 8 over 8, which is 1. So now I'm going to go back in. Wherever there is an x, I'm going to put a 1. 1 squared is 1 times 4, which is 4, minus 8 plus 1, which is going to give me 4 minus 8 is negative 4 plus 1, which is negative 3. And my equation becomes 4, because that's my a value. My x is 1, so when it goes back in, it becomes a negative 1, and then minus 3. Okay, let's try this one. So, same thing. A equals negative 3, b equals negative 12, c equals negative 17, and x is equal to a negative b over 2a, which is going to make that a positive 12 over 2 times negative 3. So 12 over negative 6, which is a negative 2. And so wherever there is an x, I'm going to put in a negative 2. Okay, negative 2 squared is 4, and 4 times negative 3 is negative 12. Negative 12 times negative 2 is plus 24, and then minus 17. So negative 12 plus 24 is positive 12, minus 17, which is negative 5. So y equals my a value, which is negative 3. My x value is a negative 2, so it'll become a positive 2 when I put it in the brackets, and then minus 17. All right. And last, here we go. So let's say A is negative 5, B is negative 30, and C is 15. X is equal to a negative B over 2A, which is going to give a positive 30 over 2 times negative 5. So a positive 30 over a negative 10, which is going to be a negative 3. So now I'm going to go back into my equation, and wherever there is an x, I'm going to put in a negative 3. And we get negative 3 squared is 9, and 9 times negative 5 is negative 45. Negative 30 times negative 3 is a positive 90, plus 15. Negative 45 plus 90 is going to be 45. 45 plus 15 is going to be 60. So my vertex then is my a value, which is negative 5. My x value, which was negative 3, when it goes inside the brackets, becomes a positive 3. And then my y value plus 60. Cool. Okay, so let's take a look at when we need vertex form. So suppose we have a model rocket. It's launched straight upwards, which with an initial velocity of 200 meters per second. The height of the rocket is h in meters, and it can be modeled by the equation h equals negative 5t squared plus 200t, where t is the elapsed time in seconds. What's the maximum height the rocket reaches? So it's this word here that tells us maximum, that I need to know my vertex. Okay, so whenever you see maximum or minimum, it's telling you you need your vertex. So if I was looking at this, I would say, but I don't have my vertex. This is in standard form. Okay, h equals negative 5t squared plus 200t. Even though we don't have a constant at the end, we can put a plus 0. This is standard form, and I want vertex form. So to do that, I'm going to have to use my completing the square method to get to vertex form. So a equals negative 5, b equals 200, c equals 0. And from here, x is equal to negative b over 2a. So negative 200 over 2 times negative 5, which is negative 200 over negative 10, which is just going to be a positive 20. So we can see there that we have an x value at 20. My y value is going to come from putting in that 20 into my expression. And I get 20 squared, which is 400, and then times negative 5, which is going to be negative 2,000. And this is going to be positive 4,000. So y equals 2,000. Okay, so then my vertex form is my same a value, negative 5. That 20 goes in. Oops, I shouldn't use y's, I suppose. I used x's and y's because I'm so used to doing that. But really, I should be using t's and h's. Okay, so let me just go back. So this really is a t, okay, because it's inside. So that's normally where our x's were. That's our t for time. Our h, that's our independent variable, or our dependent variable, because height depends on time. So all those y's should really be h's. So let me do this. H, H, H. This should be a t. Okay, so let's be consistent here. T minus 20 squared plus 2,000. Okay, and what does this mean? So it means then, if I was looking at the graph, this is 20 and this is 2,000, and there's this rocket that, you know, went off. That the vertex is right there. The vertex is right there at 20, 2,000. So what is the maximum height that the rocket reaches? Well, height is on this side and time is on this side. So it would be, the maximum height would be 2,000 meters. Okay. So definitely when you're looking for a maximum height, you want to make sure that it's in vertex form so you can see your vertex, and from your vertex you can pull out. Now, how long did it take to reach maximum height? So max height, we really should write this out, equals 2,000, whoops, 2,000 meters, and the time to reach max height is our time stamp here, which is 20 seconds. Okay, so it took 20 seconds to get over here to get up to there. Okay, 20 seconds to get to maximum height, and that maximum height was 2,000 meters. Okay, let's take a look at one more. Randy is building a fence for the side of his house. He has 120 meters of fencing and plans to use the side of his warehouse as one of the rectangled fenced areas. What are the dimensions that can maximize, whoops, there's that word, maximize area. So maximize, of course, means that we need vertex form. Right instantly here, we don't have any kind of big information other than I know I have 120 meters of fencing. So let's first start with a couple of formulas that we know about rectangles. Let's start with rectangles. Well, I know perimeter. So I have a length here and a width here and a length here. So I have 2 lengths plus a width, and I only have 120 meters of fencing. So this has to represent the perimeter of my fenced area. And then my area is all this inside. That's what I want, a maximum area. And I know my formula for area of a rectangle is length times width. Okay, so this length times width is the formula that I want to use to help me figure out my maximum area. But notice I have 2 different variables. So 2 different variables are of no help to me. I need just one variable. So what I'm going to do is I'm going to go to my perimeter equation and I'm going to rewrite this. Instead of 2L plus W equals 120, I'm going to write this just as W equals. Okay, I'm going to leave this W on this side. I'm going to move this 2L to the other side by subtracting 2L. And I get 120 minus 2L. Okay, so width is equal to 120 minus 2L, which means since width is equal to that, I can replace it in my area expression. So I get length times, and now width instead of W, I get 120 minus 2L. All right, and if I expand that in, so the area is going to be equal to 120L minus 2L squared, or how we like to write it, minus 2L squared plus 120L. And look at that. Now all of a sudden we have an equation that represents what's going on here. And I want the maximum area. So max area means vertex form. Okay, this means I want to know my vertex. So I'm going to go A is equal to -2, B is equal to 120, C is equal to 0, and I'm going to use negative B over 2A to help me get there. So negative 120 over 2 times -2, which is negative 120 over -4, which is going to give me 30. Okay, so right away, that's my X value. But see how see in my equation, I don't have X and Y's. This is L. So before I get any further, I'm going to replace this. So L equals 30. So right away, I know my length is equal to 30. So at this point right here, I mean, you can keep going if you want. But I could actually stop right here and say, I know my length is 30. So if I go back into my expression here, I know if this is 30 and this is 30, so my length is 30 on each side, and I only had 120 meters of fencing. My width was 120 minus 2L, so 120 minus 2 times 30, so 120 minus 60, which is 60. So I have a length of 30, I have a width of 60, and it asked what are the dimensions, so it must be 30 meters by 60 meters. So once I figured out what a length was, I was able to stop and just use that one answer back in. So I didn't actually have to continue on and find my Y value, which would be my A, my area, my max area. I didn't actually have to keep going with that. I could just stop right there after knowing that one part, which is great. Okay, so definitely you should keep practicing going from standard form to vertex form, but also practicing when you need to make your equations, because I think that's probably the hardest part, is coming up with the equations. And then, yeah, and then for solving it. So if you have any problems, please reach out.